Hey friends, let's investigate the greenhouse effect. The greenhouse effect, we feel it every day in the summer when you get in your car and your car is like insanely hot when it's been sitting outside baking in the parking lot. The glass is letting light in and then it's trapping the heat. As those photons try to go back out of your car, those heat photons, they bounce back and it heats up your car. That's the greenhouse effect. I've never You might not have ever been in a greenhouse effect, but you've been in a car that's been baking in the sun. Though the glass is acting as a greenhouse glass. Let's talk about greenhouse gases. Being one, we villainize the greenhouse effect. Life on Earth would not be possible if it was not for the greenhouse effect, kind of keeping us nice and warm. Mercury is the closest planet to the sun, but it's not the hottest planet. Mercury doesn't have greenhouse gases. So Mercury is like hot, half cold. But on our planet, we do have greenhouse gases. But like I told my daughter a couple years ago, when I was making this analogy, one blanket on your bed at night is awesome. Five blankets on your bed at night is way too hot. So if we have too much of a good thing, that's when global temperatures rise. Um, and that makes life unsustainable. It's going to decrease our biodiversity. So let's take a look at what makes a greenhouse gas a greenhouse gas. So here I have visible photons. So this CH4 is methane. You need to have some of these memorized. The lights going straight through. So that tells me that methane is colorless. That's not what I care about. I'm going to click on infrared. Now these are heat photons, infrared heat, and do you see that it gets bounced back? It's wobbly. If this was more accurate, I would like a bunch of these photons bouncing back. Methane has a very high global warming potential. So methane is, as this bus goes by, methane is a very powerful greenhouse gas. Hit the pause button. What do you think? Is carbon dioxide a greenhouse gas? Gee, I wonder. Let's click and let's find out. Yeah, carbon dioxide looks symmetrical, but it's actually asymmetrically balanced with valence electrons. Doesn't That's not important. What is important is that whenever photons of heat go into the molecule, sometimes it gets bounced back, and that's going to trap the heat. So definitely, carbon dioxide is a greenhouse gas. Smash the pause button. Make a prediction. What about water? Good old fashioned H2O. Let's see. Ooh, it wobbles and it kicks back some photons of heat. So definitely, water vapor is a greenhouse gas. Now we don't measure it as a greenhouse gas. Water vapor doesn't last very long in the atmosphere as vapor. It'll condense and form clouds and then fall back down. And in fact, clouds block out the sun. So it actually talks about that's called albedo. Um, it actually makes more sense to talk about water vapor as a cooling molecule, but still technically it does wobble and kick back photons of infrared heat. I feel like my camera's all jacked. So you don't need to see my face anyways. So what about N2? Most of what I breathe right there is nitrogen. Smash the pause button. Atmospheric nitrogen. No, those photons go straight through. Atmospheric nitrogen is not a greenhouse gas. That's great. We'd be baking right now if it was. Most of our atmosphere is atmospheric nitrogen. What about oxygen? Is that a greenhouse gas? Let's see. No, those photons of light pass right through, so it does not reflect back photons of heat, and so therefore oxygen is not a greenhouse gas. This is not extensive. We are missing a pretty important one. Nitrous oxide, N2O, is a strong greenhouse gas. It has a global warming potential of like 300. It's much stronger of a greenhouse gas than carbon dioxide. It's not that prevalent in our atmosphere. It's only like 6% of all greenhouse gases. Carbon dioxide is the one, it doesn't last the longest. It isn't the strongest, highest global warming potential, but carbon dioxide, of all the greenhouse gases, is the one that's most important to talk about because of its volume. It just makes up almost all the greenhouse gases, is carbon dioxide. And our combusting of fossil fuels, releasing it from reservoirs where it used to be safely stored, putting that carbon dioxide into the air is causing the planet to have an overreactive greenhouse effect. And that's what's superheating our planet, reducing biodiversity, causing sea levels to rise. We'll investigate that more next week. I hope this is helpful. Finish the rest of your hyperdoc, and I'll see you guys later. Bye. Boop.